like 100.
There are like 115 slides, but some of those are actually optional, so it's okay if we don't get through everything. But yeah, I'm going to be talking about extending ggplot2, specifically talking about extending ggplot2 with new geoms and stats. There are other ways, which are all, well, some of them good, some of them not so much. This is our focus today. So quick introduction. Hopefully, can everyone read that up there, the code? Hopefully you've all seen code like this before. So this is just classic ggplot2. Here plotting the penguins data set with geom point, right? So this is about extending ggplot2. What does that mean? Well, it turns out there are formal mechanisms for creating new geoms. So this is a big part of my research. Before that, more classic ggplot2. But this is part of my research. This is GP density. This is visualizing sort of density estimates in a mildly novel way. And this is facilitated by geom HDR. What you see is exported not from ggplot2, but GP density package. There are lots of other examples of extension. So with the same data set, now looking at univariate data, this is from ggBeatSwarm, quasi-random, which is a maybe improved way to visualize strip charts. There's like these ridgeline plots from GG ridges where we get fancy 1D ADEs. And yeah, so like this might look weird because we have classic like ggplot, this function, which is exported from ggplot2, and then we're adding layers using functions from other packages. It turns out this really isn't so hard to do. And to talk about that, we're first just going to look at geom point. So here's some data that's a little bit easier than the penguins data, just X and Y standard bivariate normal. And this is how we typically plot it, again, with this simple code. Looking at this code, a question you might have is like, what is geom point? Like, what is this thing? We know it's a function because it's, got the little parentheses, which we know take arguments. But what is that function doing? What's its definition? We can look at it, right? We can look at the definition, and it turns out it's a function of all its arguments, and all it does is put those arguments into another function. So it just calls this layer function and returns whatever the layer function returns. Well, you might think, let's just use the layer function instead, and you can't. So we can, instead of using geom point, we can use a layer, providing a geom point, stat identity, and a position argument. You'll notice this is no longer the geom underscore point function. This is not a, at least it's not a function call, right? There's no parentheses. This is some object that we're supplying to the layer function. What is that object? Well, so yeah, ggplot2 is built on the ggproto object-oriented system. So the geom point stat identity thing we just saw are instances of a ggproto object-oriented system, which are objects. It's kind of complicated, but we'll not worry about that right now. And so geom point stat identity are objects that each have methods and fields. You could think of these as elements that encode the relevant procedures, methods, whatever, for creating, in this case, a scatter plot. If we look at what geom point is, it's an object, and these are all of those methods and fields I was talking about. The simplest among these might be the default AES, or default aesthetic mappings. If we look at geom point default AES, we see that by default, geom point wants to create those graphical objects that have shape equals 19, color black, size 1.5, and the rest of these are, whatever. And so when you use geom point and you get the points, these are the defaults. A little bit more complicated, we can look at the draw panel method or function. This, we're not going to worry about too much right now, but this is how geom point translates the data that is being provided into the graphical objects being drawn on the plots. Again, we'll hit this more later. So we're not going to talk about object-oriented systems very much, but if you have any familiarity with them, you might be familiar with the concept of inheritance. Essentially, if there's an object or a class that you like, you can borrow stuff from it without having to duplicate efforts to rewrite it on. And that's the whole point of ggproto, or at least a big point, a big part of the reason behind why it is the way it is. Quick example, we can make our own geom_point new, inheriting from geom_point, just with some adjustments to the default aesthetic options. So what that looks like is we use this ggproto function. We say, hey, we're going to make a new geom, like a capital G geom, called geom_point new. And we want to copy geom_points. And the only thing we want to change is that default aesthetic field that we saw earlier. And so what we're changing is, instead of shape being 19, which is the classic points, we're doing shape equals 21. With the shape equals 21, you can actually do an outline on the point and a fill. And so we set the color to be black, which is the outline. We increase the size a little bit, and now we're filling the points with blue. If you were to now look at geom_point new, there's the default AES thing that we just defined, but we also get all of the other stuff for free. And this is going to be exactly what geom_point has. So first, looking at default AES, it's what we just defined. If we look at the draw panel, it's what we saw earlier. Again, we aren't worrying about the details, but just notice it's the same code. And so now, if we use a layer function, providing geom_point new instead of geom_point with the same stat and position, we get the plot we just had, except now the points are those sort of blue filled with black outline. So this is a simple example just showcasing what inheritance looks like in ggproto. We're going to leave defining geoms behind for a bit, because that's actually a little harder. First, important step when you're extending ggplot2, people don't like using layer functions. They like to use those like geom or stat functions, which I'm going to refer to those as layer functions themselves, because they're shortcuts, essentially. And so we can define a new layer function, geom_point new, which does exactly what geom_point does, meaning it takes these arguments, divides into a layer call. The only difference between this and geom_point is, instead of the geom arguments, the layer call being geom_point new. And so now we can just use geom_point new, and it works just like we want it to. Like I said, we're going to leave geoms behind. We're going to look at stats first. And the example for our sort of motivation for creating a stat is going to be the traveling salesperson problem. We're not going to get into the details of this. It's like a pretty complicated thing. But in essence, the traveling salesperson is, if you have a set of points, in this case, they're on like a map of the United States, and there's a salesperson that needs to travel between them. So the salesperson needs to visit each of these points exactly one time, and they want to be efficient. They want to travel the least distance possible. So that's what we have here. We have these points and a route between them. Like I said, it's a complicated problem, and luckily, other people have worked on it. So we don't have to worry about implementing the solution to it. We're going to start with this same data set that we had earlier. So remember, we had these sort of 10 binary normal points that are contained as columns in df. And we're going to be using the TSP package to solve the traveling salesperson problem. It's pretty simple. So essentially, we have to create a distance matrix from the columns of our data frame. And then we turn the distance matrix into sort of data structure that the TSP package likes, which is done as a TSP function. And then we solve the traveling salesperson problem. If we look at the tour object, which is the solution, it looks a little complicated, but it's not. It's just a named integer. And so you see here it's length 10. Well, we have that 10 data points. And the elements of this vector are the sort of order in which each of those data points need to be visited by the salesperson. And so all we do is we sort the rows of our DF by the tour objects, which again is just integer vector. And when we do that, we see this is the data frame sorted. And we can just supply df sorted to geom path, which already exists, and we can plot the route between the points. So we can see the lines are tracing between them in a way that minimizes total distance travel. This sort of workflow of taking data, manipulating it outside of ggplot into a structure which works well with existing geoms is something that we're all probably familiar with. It's not bad, like there are lots of instances where this is the way to go, but it turns out if you're doing this, if you're finding yourself doing this a lot, this is a good situation for implementing a new stat or geom. And so that's what we're going to do here. We're going to make a stat salesperson that does this part of the code internally in ggplot2. And so to do that, we're going to again use this ggproto function to create a new stat called stat salesperson. This time we're not inheriting from like a stat that you have encountered before. We're actually just saying this is a stat. And so it starts with like the basic fields and methods that all stats need, and that's meant to be filled in for whatever use cases have. In this case, all we need to supply is this compute group function, which for each group in the data, so whether that be just the data, all of the data, whether that be for data in different facets of a plot, or maybe data that's colored according to something else, it's going to compute, or it's going to transform the input data into this output data, which is sorted. And it's the same procedure. This is actually just copy pasted from before. The only difference is we changed df to data because that's what ggplot2 uses internally. And we're also being careful to only mess with the X and Y columns of data. Before df only had X and Y columns internally, and this compute group function is being called. In the execution environment, data has additional columns appended to it, sort of like metadata. That doesn't really matter too much. All that matters is we only want to solve the traveling salesperson problem for these variables. So we create the distance matrix, we formulate it as a traveling salesperson problem, and we solve it. And then we return the original data for it. The only other field we really need for stat salesperson is the required aesthetics, which is for this layer, what aesthetics need to be provided in order for stat salesperson to work. And so obviously we want to X and Y aesthetics.
So James, those would be X and Y, even if your data has different names for those aesthetics.
Yeah, that's right.
So,
yeah, that's right. So, you know, lots of times you might have in your aesthetic mapping X equals longitude, Y equals latitude. In that instance, this data, which is itself a data frame, would not have columns for latitude and longitude. Those would be translated to X and Y. And that way, that's why here, when we're pulling out the columns of data, we're pulling out the X and Y columns because that's taken care of internally, which is great. Next, we just have this, again, layer function. So this sort of convenience function where we're making a call to layer, where we're supplying, you know we want stat salesperson. The geom itself is going to default to geom path, but this could be overwritten, like if you wanted to put circles on each spot or something like that. Yeah, otherwise this is just what we saw before. Geom point new, it's just now stat salesperson. And if we take our original data frame, which again is not sorted, we just have ggplot df, we're supplying the X and Y aesthetics. And then when we make the stat salesperson call, it internally solves this traveling salesperson problem, sorts the data frame, returns it, and we get what we had before after doing it manually. You might notice it's slightly different. So earlier, like this point and this point were connected. It's just because of traveling salesperson problem, where you start doesn't matter. It's the same distance over. And it's a hard problem to solve, and sometimes you get different answers each time. Now, a lot of times these layer functions accept additional arguments. Now, we could just, right now, we could say stat salesperson color equals red, and these lines would be red. That's going to work. But, if you do stat smooth, you might want to say, instead of like whatever the default is, like the spline or whatever, you want a linear model, in which case the stat smooth has an argument that says method. We can implement similar arguments very easily. Where we start for doing that is in the definition of this compute group method. It's a function of data and scales as it was before, but now we're adding this new argument, in this case called method, and that's going to used by the solve TSP. The solve TSP function accepts the method argument itself. There are different sort of algorithms that you can use to solve the traveling salesperson problem. The default for solve TSP is nearest underscore intersection, and so that's going to be the default for stat salesperson as well. The only other change we need to make is in the definition of this layer function. We want stat salesperson, the layer function, to also have a method argument, and then we need to pass it along down here to the layer via this arrays argument. So changes there. Now, with stat salesperson, we can supply a method argument. So one argument that the TSP package accepts is identity. In this case, we're not doing any sorting on the data frame. It's just coming out like it came in. We can also do random, so just randomly choosing the next destination, or if we leave it blank, we get the default, which is a sort of a good solution. So a best practice when you're implementing stats and geons, especially when you're implementing stats, is to implement a geon counterpart. Generally, people don't like interacting with the stat underscore functions. Like you don't, I mean, there isn't a stat point, but you don't want to use stat function, you want to use geon function. And so that's all I'm doing here. I'm just saying, hey, our geon salesperson that's going to be a copy of geon path. We're not making any modifications whatsoever. And this geon salesperson layer function is just, the sort of basic wrapper around the layer. And with that, we get the code that people want to write, which is, using the geon salesperson instead. These are equivalent. Does that make sense to everyone? Yeah. Okay.
James. Yeah. So can you go back a slide? Mm-hmm. So if we were to go deeper here, so geom salesperson, capital G, right? Mm-hmm. That's going to exist as an object that's bound in your global environment, mm-hmm. Right? Mm-hmm. What about the other geom? So like geom point, right? The ggplot comes with it, right? Where is that bound?
So yeah, like the capital geom points.
Sorry,
not the layer.
I did not give James these questions.
That's important. It's exported by the ggplot2 package. And so in your sort of console, if you type capital geom points, you'll see it. And we're going off the rails. Oh, you warned me about this. Okay, let's go this way. I'll show you. So this is just our console. If I type geom, well, first the library, ggplot2. There it is, right? So it's not hidden. It's not like a non-exported object. ggplot2 doesn't mind you messing with it. And that's because what is this?
Mess with it.
Perfect. And that's because it, like geom point, capital geom point, exists, it's bound in the same spot that the layer function is. And that's so you can use it with the layer, with the actual layer function. Where is it bound? It's in like the namespace of ggplot2.
Yeah. So it would be in the namespace.
Yeah.
It's interesting because it's an example of in a package. We say the packages are bundles of functions and data. And you may say like, well, when is it data, right? In some cases it's obvious, like diamonds, right? But in other cases, it may not be as obvious. So like here, geom salesperson you're creating, geom point is not a function. Geom point is like this ggplot2 object, right? But it comes along with the package. So if you're the package developer, this would be one of the situations that's a little bit different. If you're the package developer, you would need to create the geom that you're interested in, just like line 1 here. I mean, very, very easy. But and then you would export it, but it's kind of coming across as data. It's not a function, right? But it's an interesting issue because you can kind of clobber it. So here's another interesting question. So the students have just read about environments. So if you were to create geom salesperson, or let's say you were to create geom point, okay, capital G, capital P, okay. Then you use the layer function geom underscore point, which is a thin wrapper of the function in ggplot2 called layer that internally calls geom point capital G, capital P. Which geom point is it going to get? Do you see the issue? So there's 2 geom points running around. there's the one that you defined in your global environment. And then there's the one in the namespace of ggplot2. So the question is like, well, who's calling it, right? Because internally, the layer function is going to call it, right? I mean, he showed you how if you just type in geom_point, it calls capital G, capital P, geom_point, right? Which geom_point is that?
Mm.
Okay, so we'll just leave that, because that was definitely an unscripted question.
And then later, when you use objects that inherit from geom_point, where do they look?
Right.
Because
right.
the inheriting is
Yeah,
their
it's a great
prototypes,
system.
because they're not classes, they're prototypes. So it's looked up like there. Anyways,
You could overwrite geom, capital G.
Yeah, that's a bad idea.
Question. What's that? Good quiz question.
Yeah.
It's gonna be a test, okay?
So, yeah, so, okay, I think we all get it though. We all get what's going on. We made a new step. Like I said, stats are easier because all that's happening in the stat is, the stat has a data object, a data frame, and you manipulate it and you give it back transform. In this case, that transformation was reordering it. Sometimes you might be appending columns. Sometimes you might be completely like throwing away what came in and making a new one. But in essence, you're just taking data and spitting data back out. That's not, yeah, sure.
I have an easy question. Do you need the ...
Yeah, so this ... that's a good question. I don't think I even talked about it here. But remember how I said, let's go back here. This will be more familiar. So geom salesperson. If not in the aesthetic mapping, but just as an argument to this layer function, if we said color equals red, the lines would be red, right? But there's no color argument. And the way that's handled is the color kind of goes into the ... And that gets provided to this params argument, which the layer function itself is complicated, but the layer function is going to know what to do with that color argument. And that's going to be providing it to the geom. And that'll actually factor in, how I said earlier, how the data object had columns other than X and Y. One of its columns is color. And so that color is going to come from there. That's a good question. Yeah, so geom is more complicated. So with geom, you're not just taking a data frame, manipulating it and giving it back. You're taking a data frame and turning it into like the pieces of the plot. Like geom segment is taking a data frame and making the segments. And so our example here is going to be the complete graph, or the notion of complete graph. We're not going to get into like the deep mathematics of this, but here are examples of the complete graph on 2, 3, 4, 5, 6, and 7 nodes or vertices. The complete graph is just if you have these points, which again are called in graph theory vertices, drawing an edge between all of them. So in here we've got one edge connecting these, we have an edge connecting this point to this point, this point. This point is connected to all 3 points, etc. And so, let me go back. Looking at these examples, the complete graphs have like a sort of characteristic look to them when the points are sort of circumscribed on the unit circle, which is that's what's happening here. And so to illustrate the process of creating a complete graph in ggplot, we're going to have a circle, right? So we're gonna have X and Y, which are sort of 10 points along the perimeter of the unit circle. And this is what we're gonna start with. So again, we're not going to jump straight into creating the ggplot extension. Instead, we're going to manipulate this and plot it as you typically would. To do so, there are lots of ways you could do this. The way that I did it is I took the data frame and I copied each row by the number of rows in the data frame. So in this case, there are 10 rows, and so I duplicate each row 10 times. So we end up with 100 rows. And there are sort of sets of 10 in this case that are all the same. Does that make sense? Next, in order to identify each of these rows with each of the other rows, I make another column, which is just the original data frame each time. So you can see the first 10 rows here are all the first point in the data frame being connected with all of the other points, sort of handshaking. This is just like
kind of like a Cartesian product. I've named these columns X, Y, X end, and Y end because now we're going to use geom segment again. And now we're specifying these X, Y, X end, and Y end aesthetics. When we do that, we wind up with, now this is a complete graph on 10 edges. Like I said, this is sort of taking data, manipulating it outside of ggplot, and then putting that manipulated object back in. But like before, there's an opportunity here to sort of factor that out and put it into the definition of a custom geom. But we're not going to get there yet. First, we're going to talk about graphs. I mentioned before that geoms are different than stats. Stats take data and in the form of a data frame and then transform it and give it back in the form of a data frame. Geoms don't do that. Geoms take in data and then give grobs back. Now, grobs are the fundamental building block of graphics in R. It makes sense to you. You could think about them as graphical primitives, essentially. In ggplot, whenever you look at a plot, everything is a grob. Like obviously the points are grobs and the lines are grobs, but like the axes lines are grobs, the ticks are grobs, texts are grobs. And is talking about extending just geoms. Grobs are what geom classes use to draw. A good reference, by the way, is this book, R Graphics by Tom Girl. It's all about grobs and grid, which is the package where grobs come from. So an example, not in ggplot2, is we can create using this function from grid, which is segments glob, a set of line segments. And we're going to bind those to this, line segments. And then the way that you draw grobs outside of ggplot2, just how you would typically draw them, is by calling grid.draw. So providing this line segments object, and we get it drawn. This is not a ggplot2 graphic. This is just an R graphic. You can see the segments grob is accepting these arguments, which correspond to what we had before, except instead of X and X end, it has X0, X1. If we look at geom segment, and we look at its draw panel method, this is how geom segment takes data and turns it into grobs. This is long and complicated. That's because ggplot2 is itself long and complicated. It's made by people that really know what they're doing and they're being very careful, which is great. We're not going to do that, but let's just look specifically at what this drop panel function is returning. It's returning a call to segments grobs, which is just what we just saw. And we can see that it's providing chord $X. We'll worry about what chord is in a second. But essentially it's providing the X, Y, X end, and Y that the layer is getting in. And it's doing other stuff too. But notice the whole point of drop panel is to turn the data into a grob. That's what's happening here. So if we want to do geom complete, we need to turn the data into a grob. In order to do that, we're going to define our own draw group. Notice this is not as complicated as ggplot2's, that's okay. So draw group, again, we have got this like function of data, panel params, and chord. These are all things that ggplot2 knows what they are and calls draw group with these arguments. I do. So the first thing that we do is we manipulate data. This is just what we did before. This is our Cartesian product code, copy paste it, where we repeat each row of data. And then we sort of create these new X and Y end columns by repeating data in a different way. Next, we transform it. And we're going to talk more about this on Wednesday. But the general idea of what's happening here is we're taking the data, which is defined in terms of like the data units, and we're turning it into the plotting units. You don't have to know too much about it. Just know that chord is going to have the same columns as data expanded. They're just going to be in a different coordinate system, essentially, or different units. Next, we call segments grob from grid. We're providing those, and this looks just like the ggplot2 code, where we're providing the core $x, y, xn, and yn, which defines sort of beginning and ending of each segments along each axis. And then we're providing these aesthetics. So this hits on Randy's question from earlier. These like core $color, alpha, line width, and line type are all coming originally from up here from the default aesthetics. But if we overwrite them using like the additional parameters to the layer function, then these will reflect whatever the user specified. Or if there are other mappings flying around, we will obey them. So yeah, our draw group ends with this call to segments grob. Then this segments grob object will be kind of passed around internally in ggplot2 until ggplot2 does its version of grid.draw and creates the final graphic. The other things that we need for geoncomplete to be functional, like before, we have to specify which aesthetics geoncomplete needs in order to create the graphic. We also need to come up with default values of aesthetics that are not required because the users don't have to specify them, but they are required to ultimately draw the graphs. They have to know, ggplot2 has to know what color should the line segments be, what should their line width be, their line type, and their alpha values. Finally, we're specifying this draw key thing. Don't worry about it too much. Essentially, this is how ggplot2 knows how to draw a legend. So if you have different colors, it's going to draw a legend using the same glyphs or symbols as the geon path does. After we do all of this, we just need to do this again, bin wrapper around the layer function. This time, it's on the geom side. And so the user can override the stat. So the stat is an argument to this geom underscore complete function. And then there's this call to layer function, which we're hard coding it to point at geom complete. It's pointing at whatever stat is specified, etc. And then here we go. So we have our original data. This is not the expanded data, and we're just providing the X and Y values, right? We're not worrying about X and Y, and that's going to be done by ggplot. And then we have this call to geom complete, and here we go. Here's our complete graph on 10 edges. Yeah, pretty simple. Cool. So we can do this with our other data. So remember, this is not a circle, so it doesn't look like, it doesn't look nice. But this is the sort of 10 observations that we solved with the traveling salesperson problem on. And you can just get the complete graph on. Does that all make sense so far? Does anyone have any questions? This is going much faster than I thought it would. So I'm like, am I just blowing through? Yes.
ggproto just in ggplot2 when you load it.
Yeah, so ggproto is also exported. So it's just not something people typically mess with, but it's there. Yeah. And that's how, you create those ggproto objects by inheritance. Any other questions? Oh, yeah.
You said that it's not typically something that people mess with, but is it something that people could mess with if they wanted to?
Well, when I say mess with, I just mean use.
Okay.
So like ggproto is not something that the average ggplot2 user is going to be interacting with. Mess with, I guess, loose term. No one is out there making changes to ggproto, the function. I hope. They're not good.
It has kind of an interesting history. So ggproto came maybe 7 years ago, something like that. There was a package that hosted an object-oriented system called Proto that Hadley originally built ggplot2 with. Okay, and it was because he needed to have some special stuff about mutability and things like that in terms of objects. Okay, but as packages do, this one was worth it, and I think it was. In any event, there was stuff that object-oriented system, Proto, kind of didn't suffice for this now much larger package, ggplot2, after it had lived for some time. So really, they needed to kind of bring it in-house to do stuff with those objects. And so Winston implemented ggproto, I think originally actually as a separate package, but then it was kind of like part of ggplot2. But in doing that, Winston gained like a lot of knowledge about object-oriented systems. So now he's implemented like all these different object-oriented systems. Because he learned from implementing ggplot. But you would never use it outside of ggplot2.
We're gonna see why at the very end, because prototypes. But yeah, and another part of the reason that ggproto was created was because actually it has to do with the question you asked earlier about redefining geom point. Because stuff was happening in the proto namespace instead of the ggplot2 namespace, and they did it all to be in ggplot2 because the extension was
That
just
even makes more sense.
yeah. So any other questions? Probably, hopefully not about where ggproto happens.
Let's do a proto deep dive.
Yeah. Okay, well, we'll keep going. So a classic question for me, probably not for you guys, is what's happening here statistical or graphical? So we're taking the data and we're doing that Cartesian product, and we're turning the results of that into line segments. But you could frame that as we're doing a sort of statistical or mathematical transformation on the inputs X and Y, and then we're drawing line segments between them. Or you can frame that, the way that I framed it here, as an all graphical operation. And so what this question is really getting at is, should this be a geom or a stat? And so there's not really anything out there that I found that says definitively this should be a geom, and this is what geom should be and this is what stats should be. But my understanding is that stats are used for transformations of data, and that geoms are used for converting data structures into visual representations. Now, transformations, asterisk, sometimes these are statistical, they're called stats. That kind of comes from statistical transformation. But the transformations that stats do are not always statistical, they might just be mathematical. Or they could just be really simple data, Anyways, geoms are used for converting, but also sometimes for simple transformations of data. So you can already see there's overlap. And so maybe some general things to keep in mind if you have something and you're trying to decide whether its implementation should live in a geom or in a stat. First, think about, can you make a stat which plugs into a geom that already exists? So this is what we did with stat salesperson, right? We could have implemented a geom salesperson, but that would involve getting into grid and all of that stuff when that's not necessary. All we have to do is transform the data and give it to geom segment. Another consideration is, what does a user want? So, geoms and stats have prescribed pairings, stat smooth and geom smooth are used together, but it's easy for users to override that. And so if you think about, well, what would my user rather be able to do? Would they rather use my logic as a stat or a geom? Are there use cases to pair this logic with a different stat or a different geom? That's something to keep in mind. Another thing is which is easier. So almost always stats are easier because you don't have to mess with grid. I cannot stress that enough. Sometimes it's worth digging in, sometimes not so much. If I were to do for real geom complete, I'd probably make it stat complete, even though it's just because it's personal preference. Lastly, do you need both? I keep on mentioning stat smooth, geom smooth. Those are both necessary. You could not put all of the code for one of those into, you can't put the smooth, the logic to make that smooth line into the stat. The stat has to have a statistical part, and geom has to have a drawing part. So yeah, those are things to keep in mind. Now we're gonna go in a different direction. We've seen how to make ggplot2 extensions, but I haven't really motivated why you should make them. If you're a fan of ggplot2, maybe you don't need that motivated, but it's not clear why you should go and learn about ggproto, why you should learn about grid, if you can just do what we did before making the extensions, which is manipulate your data into the right form and plug that into existing geoms or stats. But there is reason. So if we look at the traveling salesperson problem, this was the way that we could take our DF data frame with columns X and Y, stored it and plotted. So it's like 9 lines of code. That's not bad. You can copy and paste that forever. But what if you want to plot multiple routes? So in this case, we have very similar data, but now we have 30 rows, and each set of 10 rows is its own like class or route or whatever. So if we look at this, we have our data frame with X and Y in this additional column class. The first 10 are all class A, we have class B, we have class C. And so what do we need to do if we want to plot the solutions to the traveling salesperson problem for each of these classes, but we don't use like ggplot2 tools, we do it all outside. We split, apply, combine, which you all talked about. Okay, awesome.
Never heard of it.
Ready fails,
Yeah.
retrospectively.
So the first step in the split, apply, combine strategy is splitting. So we're going to split up our data into elements of a list. So we have this df split object, which is a list of 3 data frames, right? Which correspond to the rows A, B, the classes A, B, and C. After we split it, which you can see here what each is, so df A, B, and C. After we split it, we need to apply. Apply meaning we need to solve the traveling salesperson for each element of df split. Ideally, somehow at the same time without copy pasting. And that's not too hard, right? So we have our df split, which at this point is a list, and we're going to apply the dist function, turning each element into a distance matrix. And then we'll apply the as.atsp function, turning each of the distance matrices into a traveling salesperson problem. And then we will solve the traveling salesperson problem on each of those elements. And at the end, we have our class underscore solved object, which itself is a list. But now the elements of the lists, where before they were data frames, are named integer vectors. Each of these encoding solutions to the traveling salesperson problem for each of our original data frame groups. Now, we're still on apply technically, because it's not enough to have the solutions. We actually have to reorder our data frames. To do so, we just make this sort of helper function that reorders the rows of the data frame and apply that across our original data frames according to class solutions. This code is complicated, you don't have to worry about it too much. But in the end, we get our df split order, where now we have a list of 3 data frames with columns X and Y, and each of these data frames are sorted according to the solutions traveling salesperson problem. If we look at the elements of df split ordered, A is the rows of the data frame of the original data frame. Rows 1 through 10 of the original data frame, which corresponds to class A. And now you can see that the row names are kind of jumbled, and that's because they've been sorted, right? Similarly for B and C. Last step is combine. So we sort of just unsplit to turn our list of data frames into just one data frame. And we need to be a little careful about the class column getting preserved. And here we go. So now we have our class A observations. And again, you can see they've been reordered. B and C. So we're ready. We can provide GF multi ordered, which is that thing that's been sorted, saying, hey, we care about the X and Y aesthetics, and then facet based on class. And geom_half draws the segments between the rows of DF multi ordered in the order that they show up, which we were very careful about. And now we have these 3 solutions. It's a pain. Like, that's a pain. And we do stuff like that all the time. Like we do split, apply, combine all the time, and it's fine, but we don't have to in this case. Because if we implement the geom TSP, we can okay, it's a pain, right? But ggplot2 can do all of this. You might have noticed when we were implementing the geoms and stats, the functions that we were creating, or like the workers functions in those objects were titled like compute group or draw group. And that's referring to like what code is called for each group in the data. And so if, so here I'm just showing you how it works. If we just, this is our original data frame. It has not been split applied combined, combined. And all we need to do is say use geom salesperson and facet it by class, and like magically it's plotting the three solutions. And that's because that compute group is being called for each facet. And you know, we can go further, right? We can throw it all together and we can say draw complete graphs for each group, do the salesperson solution for each group, and do the points for each group. And you know, this is a cool graphic. Like, what is it showing us? It's showing us if each of these points is a city and there's a road between each city, which path, like which set of roads is our salesperson taking that's the quickest. If you wanted to create this without the extension, you would have to split apply combine for the complete graph and for the set and for the salesperson, and then carefully, you know, have like layer calls with different data arguments. So that's not necessary. We can just lean on our implementation. And like I said a couple times, the reason that this works is because the ggplot2 functions, or the ggproto objects, know to dispatch, or you know, or however you want to say it, from layer to panel, or from panel to group. There's a hierarchy. And so ggplot2, whenever it's supposed to plot something, it starts at the sort of layer level, which is all of the stuff that's going to be drawn by that layer function. And then it breaks that into a panel level, and then that breaks it into a group level. And so let's look for a second. Again, this is complicated ggplot2 code, which I would encourage you to look at, but we don't have to right now. This is geom complete, the one that we wrote earlier, looking at its draw layer method. Remember, we didn't define this. This actually came for free because geom complete is inheriting from the geom class, which were objects, which itself has this system. So what is this doing? Well, here's the function, and it's using lapply on the split data, splitting it by panel, which you know refers to the faceting, and the lapply itself is calling draw panel. So the draw layer is splitting up by panel and then drawing for each panel. This is like exactly what we did with the split apply combine. It's just already done for us and better. I had to debug. I spent like probably a day getting this split apply combine stuff to work because I kept on messing it up just because it's finicky. But you know, ggplot2 is never going to mess that up. Similarly, if we look at compute layer, which again, stat salesperson got for free because it inherits from stat. It's complicated, but if we look, it's doing dapply, which is a ggplot2 function. It stands for data apply. It's applying across the panel, which again is a column of data internally. And it's just doing compute panel for each one. If we looked at the definitions of compute panel, you would actually see a very similar pattern where it's splitting by group, and for each group calling compute group, where compute group is what we defined originally. I just didn't show that because it's the same. Does that make sense? So do you guys see how internally ggplot2 is doing the same split apply combine as we can do worse on our own? That makes sense? Okay, cool. So we have reached the end of this presentation essentially, which is awesome. So here are some resources. So first is Hadley's book, ggplot2. It's a very good book. It's in the third, almost in the third edition. And in the third edition, he has a chapter near the end on writing extensions. He actually has another chapter on ggplot2 internals. Both of them are very good. And so if you actually want to write like ggplot2 extensions that you want to bundle into a package or something, definitely read this. He talks about a lot of the details that I skipped that actually matter. Like for example, dealing with like flipped coordinate systems or grabs more complicated than segment grab. He goes into all of that in a way that you have to know in order to actually write like robust extensions in ggplot2. There's another thing written by, I think, Hadley, which is the vignette that comes with ggplot2 titled Extending ggplot2. It's good. It's shorter than this chapter. It came before this chapter, but it's sort of another good introduction. Also, if you're interested in developing ggplot2, one of the biggest resources is actually ggplot2. So looking at its source code, if you go on GitHub, you can just see how did they code geon point, how did they code geon segment, and you're going to run into a lot of weird errors, and this is the way to figure out how to do it right. Essentially, along those lines, there's a really nice package called ggtrace, which allows for like interactively poking around in the execution environment of all this ggproto stuff. It's not too complicated, but it really helps build up an intuition of, for example, if you remember your original Randy's question about the like, what is the ... used for? And I talked about how that data frame actually had several columns besides X and Y. You don't know that unless you actually can poke around in the execution environment of compute or draw group. And that's what ggtrace allows you to do. Browser, the like base R function lets you do too. It's just ggtrace better. And then finally, again, there's that R graphics book I would definitely recommend. So that's it. I have additional stuff, but I don't know if we have time to go through it all. Does anyone have any questions? Yeah.
When you said you could go on GitHub and like look at how they coded geon point or something, is it like explanations, or what's different on GitHub than like just typing in geon point?
Yeah, that's a good question. So there are a couple things. First, it's easier to read on GitHub.
Okay.
Like, reading it in your console is like a pain. There's no syntax highlighting, and there is on GitHub. You can also, the real solution is cloning the GitHub repository onto your local machine and then looking through those files. Does that make sense? Does everyone know what I mean by that? Which is sort of the intermediary between the things that you're saying. Also, I believe that if you write geon point, you lose comments. Like, I think that at some point R decides to take all the comments out.
Okay.
Is that right?
That's right.
Yeah.
When R is bundling a package together, it strips out all comments.
Yeah.
And all formatting. So you might have realized, and you saw this even when James showed like the definition of geon point, for example.
Oh, yeah.
Like that, there's just kind of like code everywhere. And if you turned it in, like, I would definitely count off. It's like impossible to kind of like tell, because there's like nested function calls, but there's no rhyme or reason to the alignment. And it's because when you bundle up something to send it to CRAN, it's going to strip out all that kind of stuff. But if you go to GitHub, you can see kind of their native code. Yeah. So one of the big secrets about GitHub, that's not a secret, is that it's a fantastic learning platform, right? Because you can see, if you want to see how did they implement geon box plug, right? You can just go to their code, and you can actually, it's better than seeing it in R, because you can see it formatted, but very often they'll put little comments to themselves about, like the developers of ggplot2. Oh, we did it this way because of X, Y, Z. And that just gets totally removed if you're just in R. But it's a really good question.
Also on GitHub, it can be helpful to look at like revision histories. And
Yeah.
so like this has just happened in my research where like I ran into a problem, I was Googling it, and I figured out that ggplot2 devs had also run into that problem. And I was able to like go through this rabbit hole of GitHub issues and like Git blames and stuff to figure out, well, how do they fix it? What was breaking for them, and how can I fix it? Yeah, so they're both good. If you're just working quick and you're like, oh, what's the argument? Then just type it in the console. But past that, either go to GitHub or, like I said, clone it and use like the nice RStudio IDE tools to mess around in that directory. Does anyone have any other questions? Cool.
I have one comment, and that is on the previous page, you were talking about Paul Murrell's book.
Yeah.
He also has a long paper, and I can't remember off the top of my head if it's in the American Statistician or the Journal of Statistics Education, that's on the grid system. So instead of getting the whole book, you can get a good introduction to grid that way. Just Google Scholarly, but I can't remember which one it's in, but I think it's pretty long paper, maybe like 40 pages long. But a lot of it's pictures and kind of thing. But it explains how the grid system works.
Cool. Yeah, and his book's not free, but on the website, he has all of the plots from the book and all of the accompanying code. And so that's my main way that I interface with it. I just look at his code and copy it. I'm like, oh, cool.
Try to infer what the book said.
So like I said, there is more stuff I want to get through, but I don't think 15 minutes is enough. So let's wait. Oh, yeah, awesome.
Did you need to implement any new geoms when you're creating HDR, or is that using old ones with stats?
So most of the stuff in ggdensity is using the same geoms that ggplot2's geom density 2D uses. But there is an exception. I think there's just one exception, and that's the geom HDR rug, which you probably haven't seen. But essentially, you know, there's the stuff that I showed you in the very first slide was those two-dimensional sort of KDE contours, which everyone recognizes. But you can also get one-dimensional highest density regions. And the way that we visualize that in ggdensity is on the margins of the plot, having bars that are colored according to their sort of highest density regions. And that was all I had to go into grid and figure out how to do that. And to do that, I looked at the ggplot2 source code and figured out how they made geom rug, which itself plots on the margin, just in a different way. But yeah, like I said, I think everyone tries to avoid writing geoms because it's torture. This is terrible. But you guys are gonna have to, so buckle up. But yeah, well, so I was gonna say one more thing on that. What was it? No. Oh, there is one more way to avoid writing like grid stuff, and I don't get to it here. I might talk about it on Wednesday. I'll talk about a couple of extra things, but essentially there's another method in the geom object, which is called like prepare data or clean data or something like that. And if you have a very simple manipulation, like a very small tweak you want to make to an existing geom, instead of rewriting the draw stuff, you can sort of intercept the data before the geom gets it and like make a quick change and then say, okay, now you take it from here. You go ahead and draw the graphs like you know how, which we almost could have implemented geom complete like that. The problem is that sort of interception does not get split apply combined. And so it kind of falls apart if you have complicated stuff going on. Yeah.
All right, any other questions for James today? All right, great. I thought you were going to say, there's one way to get away from grid, and that's to use ChatGPT to talk about bullet.
Oh, I tried. I actually tried. I tried to get ChatGPT to write a geom, and it started out great, but it did not end great. It actually wound up having a for loop where for each instance in the for loop, it made like an individual point using the geom, like the grob function, which does not work. Does not work at all.
But there's like enough basic tutorials out there that do some really jank way like that.
I bet
It's
that's
like,
right.
That's how you do it.
Yeah.
Or loop.
Incorrect.
All right, let's thanks James today. We can be done here today. We don't need to go any longer. So we'll see you again on Wednesday, okay? Thank you.